Hi, my name is Dean. This is
I'm Marvin.
and
I'm Dinesh.
And I'm Shafan.
yeah, today we are going to discuss the physics unit 2 energy and work theory. There are lots of examples to relate this theory to real life situations, but we are choosing roller coaster as our application to portray our understanding of physics theories, and we want to analyze how physics is used to bring this right.
The reason why we choose roller coaster is because it has a huge connection to many physics ideas like work done, inertia, conservation of energy, transfer of energy like kinetic and gravitational.
Roller coasters are believed to have originated from so-called Russian mountains. The roller coasters are specially constructed ice hill, and it was constructed during the 15th century around St. Petersburg. The first roller coasters was actually built under the influence of Catherine the Great, who was the Queen of Russia. And in 1820s, roller coasters were first developed, but not for amusement, but to actually bring coal from a mine in Pennsylvania. So roller coasters that flows from the top to the bottom is to carry coal, but not for amusement. So mules are the people, those who worked in the coal mine in Pennsylvania, and they were the first to ride the coal roller coaster. See, physics being so special, the first roller coaster was built in Coney Island, Brooklyn in 1884 by the Americans. Since the early days, roller coasters have grown tremendously in terms of height, speed, and the track. We cannot just rely on the old roller coaster to actually seek thrills. So many physicists and many engineers, they have come up with new technologies to bring good nerve-thrilling roller coaster ride into the theme park today. So for examples will be
We use work done, which is force times displacement, to calculate the position of roller coaster when we move the roller coaster from below to the height, the initial position of the roller coaster, which is near to GPE, gravitational potential energy, which is when the taking place when a force acts upon a roller coaster to cause up with the displacement. And roller coaster works by gravity. These are no motors used to power the aid during the ride. From rest, it moves down a step hill and converts the started potential energy into kinetic energy. Now we will talk about the potential and kinetic energy. Potential energy is the energy stored in the roller coaster due to its position. A kinetic energy is when the roller coaster energy that is possessed due to its motion. Basically, when the coaster gets higher in the air, the gravity can pull it down a greater distance. There's the presence of potential energy. The potential energy that the roller coaster will going up the hill can be transformed as kinetic energy. The energy of motion will take the roller coaster down the hill. Means once the roller coaster starts moving down the hill, gravity takes over, and all the hill potential energy changes to kinetic energy, which is transformed into kinetic energy. Gravity applies a constant downward force on the roller coaster. Conservation of energy, which means we use work done to bring the roller coaster top of the hill and transform the from work to potential GPE, which is gravitational potential energy, and to bring down the roller coaster, which GPE transform into kinetic energy. And this shows us that no external energy from outside. What happens when the roller coaster is going through a loop? Means the roller coaster is moving in a circular motion, which means there's centripetal force, a force that acts on roller coaster in a circular path and it's directed towards the coaster around which the coaster is moving in the circular motion. This shows us the energy is conserved during this roller coaster ride. So overall, the total mechanical energy, which is the initial mechanical energy and the final mechanical energy, is equal, which is constant. Means where the initial kinetic energy is equal to the final kinetic energy, while the initial potential energy is equal to the final potential energy. There are no changes, it's constant.
Okay, there are 15 forms of roller coaster, most of it designed in an innovative way on how the rider is positioned to experience the ride. There are numerous famous roller coasters around the world, such as fourth-dimensional roller coaster, flying coaster, and stand-up roller coaster. Fourth-dimensional roller coaster. The rider will be rotating independently in the orientation of the track. It is generally about the horizontal axis that is perpendicular to the track. Flying roller coaster. The rider will be hanging below the track and face down with their chest and feet fastened with track. Therefore, you will feel the sensation of flying in the sky. Stand-up roller coaster. A stand-up roller coaster is a roller coaster designed to have passengers stand up through the course of the ride. The roller coasters are very intense and generally carry taller height restriction than other rides. However, traditional roller coaster is still the most popular ride, which rider will sit facing forward in the coaster and experience a 360-degree rotation, circular motion over the loops. Roller coaster can distinguish by their track structure, which is wooden and steel track. Wooden track is similar to the traditional Broadway track. The car will have the same flank design as the wheels of the train. The inner part of the wheel has a wide lid that keeps the car from rolling off the side of the track. Other than that, the car also has another set of wheels that keeps the car from flying up to the air. Loop steel. The range motion is greatly expanded in steel roller coaster. The track consists of a pair of long steel tubes which is supported by a sturdy and lightweight structure. The design keeps the car securely anchored to the track, which is essential when the car runs through the circular loops. Most of the modern roller coasters have the ability to run over more than two at once. And the block system controlled by computing prevents collision happens. The sensors that are attached at the end of the block, it detects when a train passes so that the computer running the ride is aware of which train is occupied. Roller coaster is different from passenger train as it doesn't have engine or its own power source. For most of the ride, the train moves by gravity and momentum. To build the momentum, the train needs to proceed up to the hill in order to gain adequate potential energy to supply a powerful launch. So, modern roller coaster can accelerate up to the speed of 200 km per hour in just 4 seconds. The fastest speed that roller coaster can travel is up to 240 km per hour. It is known as Formula Rossa in United Arab Emirates.
Okay, let's now talk about the mechanism by which a roller coaster works. The traditional mechanism is a long length of chain running up the hill under the track. The chain is fastened to a loop which is wound around a gear at the top of the hill and another at the bottom of the hill. The gear at the bottom of the hill is simply turned by a motor. This turns the chain loop so that it continuously moves up the hill like a conveyor belt. The coaster car grips into the chain with several chain dogs, sturdy hinged hooks. When the train rolls onto the bottom of the hill, the dog catches onto the chain hooks. Once the chain hook is hooked, the chain simply pulls the train at the top of the hill. At the summit, the chain dog is released and the train starts at its descent down the hill. Now let's talk about the catapult launch game. In some new roller coaster designs, a catapult launch sets the train in motion. There are several sorts of catapult launches, but they all basically do the same thing. Instead of dragging the train up to a build-up of potential energy, this system starts the train off by building up a good amount of kinetic energy in a short amount of time. One popular catapult system is the linear induction motor. A linear induction motor uses electromagnets to build up two magnetic fields, one on the track and one on the bottom of the train, that are attracted to each other. The motor moves the magnetic field on the track, pulling the train along behind it at a high rate of speed. The main advantage of this system are its speed, efficiency, durability, precision, and controllability. Done. For society, safety on a roller coaster is also a very important issue. So once we are in a roller coaster, we will be secured by two restraint systems, a lap bar or some variation over an over-shoulder harness. Don't be alarmed if we are on a loop roller coaster with a lap bar as we saw earlier. The restraint system and everything else on a roller coaster is completely computer controlled. Programmable logical controllers, usually 3 of them, monitor every aspect of a coaster's operations. They regulate the rider's speed, ensure the train never comes too close to one another, and alert the human operators to technical glitches or track obstructions. There is no possibility to say that the rider would leave the station with an unsecured safety belt or an attendant would forget to apply the coaster's brake. So all coasters are carefully inspected on a daily basis and completely worked over during the park's off-season. So don't be afraid to go on a roller coaster, enjoy and have fun.
Roller coaster impact environment positively and negatively. It is true that roller coaster does not produce carbon dioxide, carbon monoxide, and other harmful gases. But are we right to judge that way? We have to look at how it is made, how roller coaster is made. For example, roller coaster use wooden structure to support the track in order to construct a large amount of wood or logs. Construct these lines, thus a lot of trees were used which increase deforestation and further lead to greenhouse effect, which we know that CO2 ratio is not very much bigger compared to other gases, but still greenhouse effect is there. The components are supported on a concrete foundation and are joined with bolts and nails. Steel plates are used to reinforce critical joints. Roller coasters usually occupy large space in amusement park. However, the space used for the roller coaster transform thus destroying ecosystem which used to be there. The same goes for steel roller coaster, which even have higher force. When it is manufactured, millions of work are used to pull the burning steels. A lot of machineries are used to make the steel much stronger. So this includes the input of energy to actually work those machinery and make it into a large, strong steel, so which can be used for roller coaster ride as a support of track. So often harmful gases are released from the steel manufacturing factories like sulfur dioxide. It can cause acid rain. So we have to look upon how dangerous roller coasters are made, but we just look into how roller coaster doesn't release CO2 or carbon dioxide, any gases, atoms, molecules in the amusement park. So we have to first analyze how it is affecting while making those. So it's not always good environmentally.